Okay. And I'm sharing screen, right? Okay, cool. So let me start by a couple of announcements and then let me show you guys the plan. So today is November 7th, Friday. And then obviously, there's like finals, there's like, Thanksgivings and things like that. Obviously, I'm not gonna have you guys all come here during Thanksgiving. That'd be crazy. So what that means is the last week, which is Thursday, of course, Fridays included, of November is Thanksgiving. Make sense? So obviously there's no class on that day. Good? Make sense? Okay. So it means that we're having class today, next Friday, and 21st. Make sense? And then the last Friday in November is 28th. So no class. Question? Clear? Okay. And then the first week of December, the Friday will be December 5th. We'll do that class on Zoom because I have something that I have to take care of and I have to move and all that stuff. So I have a bunch of things at house I have to take care of. So we're gonna do that over Zoom. And that will be the last class. Make sense? And then after that, obviously you guys have finals and things like that. So we're not gonna go crazy. And then I'm pretty loose on deadline. So if you need like a week, 2 weeks, 3 weeks in December to work on a final project, that's totally fine. But I would say in general, to make both our life easier, you should probably submit your final project by like just sometime during the final week. I would probably say December 12th, Friday. If you can submit, that would be great. If you need more time, that's totally fine. But then that runs into risk of, okay, then you have to do the project at the same time as doing other finals. It's not a problem for me, but then you guys are probably in stress. You know what I'm saying? So any questions? I'm gonna write all this down, and then obviously this is recorded. So if you guys forgot about it, that's no problem, right? I'm gonna record everything. So in terms of the dates, any questions? Good. Okay, great. So with that said, let me show you guys the basic content in terms of the submission. So the basic thing of the submission, maybe I should just open up a Word document. I'll type this out clearly on the course website, but for now, just bear with me. I don't even remember when's the last time I used a Word document, but this is fine. So basic item for final submission. So I would say the most basic thing is there's need to be some sort of GitHub repo, right? Because you're doing a project and then they're doing some sort of Python code and Python code need to save somewhere. Don't email me with 50 Python scripts. Like that's too difficult to follow. So there need to be some sort of GitHub repository, and that would be like number one item. So GitHub repo. Depending on what project you're doing, there are different ways to structure the GitHub repo. But I would say the bare minimum, you should at least have like a README file, like one README file to tell me what to read. That's all I'm asking, right? Yeah, come on. So I would say one README file. So I know what to read. Like if you're doing like a Python project, then you should say, okay, this is a Python script, and this Python script is doing whatever. Then I know what to read about. So that would be like number one item that I will take a look at for the final project. Any questions? Good. Okay. Should be pretty straightforward. The next item is a 2-minute video, and I would say just save this in the repo. Make sense? Just save this in the repo. The 2-minute video doesn't have to show your face. It's literally just share a screen and say, okay, I built an app, I can talk to it. This is a chatbot. And if you talk to it, it will do this other thing, whatever that is, right? If it's an app, it's an app. Like if it's a page, it's a page. If it's like whatever, like a data science model, then it's data science model. If it's a picture, it's a picture. But you need to at least show in the video, like you did it and then you know how to play around with it. Doesn't have to be like completely live on Hugging Face and all that stuff. As long as you can locally deploy it, like Streamlit run app.py or something like that, then we're good. Make sense? Any questions? Okay. And then the last thing is going to be submitting. I forgot to say something about a PDF. So this PDF, my recommendation is to use Overleaf because Overleaf has template, and I'll show you what that means. So recommendation here is to use Overleaf, and to use and to use template. So all that's saying is basically this website. Let me show you where that is. Basically, it's this website. And then if you go to template, you can pretty much use whatever template you like. And then I'll tell you the bare minimum that I personally look at. Let me log in, one sec. Okay, so I think we mentioned this before. Let me just take a quick look what this is. So this website is called Overleaf. It's basically a website that allows you to use LaTeX to design PDF. That's all there is. And then it will render PDF just like that. In this case, it's a poster. You can go with a poster or you can go with a small paper. And then we'll talk about all of those things. So let me go to the Word document. So Overleaf, template. Okay, so template. The inside of this template, you can go with two styles, right? Number one is the poster. Poster is basically just what I just showed you here. It doesn't have to be like the font size is too small here. It doesn't have to be this small font size. I'm kind of like expecting you have like a picture somewhere there, and then like a table somewhere there. As long as you can fill up a space, it's fine. Make sense? So something bare minimum. Poster kind of assume that you are doing some sort of data science project. Like if you're doing like a demo of a chatbot, it doesn't really make sense to use poster, or it doesn't quite make sense in my head unless you can make sense out of it. Then that's fine. But typically, poster means you're going on a poster session. There's a model that you're building. Here's the accuracy. Here's a graph, like that sort of thing. So that implies that your final project, if you're submitting a poster, that implies the final project to be like some sort of data science project. Make sense? Which is totally fine. But if you're doing like a chatbot demo, then you don't have to, right? And same goes with the video. This 2-minute video, if it's a chatbot, it's just a video of the chatbot, right? If you're doing a data science project, presumably the 2-minute video will be just talk about the poster. Make sense? Any questions? So they're kind of like dependent of each other, just depending on what you do. So that's that. And then poster is one thing. A second thing obviously will be a small paper. The paper is kind of like my personal my personal flavor of reading a small paper will be something like 2-page. The reason it's 2 pages because if I say 1 page, people are gonna use half a page for reference. Then you just write 1 paragraph, then text me, that's not so much of a paper. You know what I'm saying? So 2-page, and then obviously there's like a graph somewhere, there's like a table somewhere if you want to. The paper can actually be like if you're building some sort of chatbot or some sort of web app, you can insert that into a paper, and you can say this is a system that you're building. And then at that point, the paper will actually kind of sound like a system walkthrough, if that makes sense. So kind of like an instruction manual. Exactly, yeah, like a README file. So it's not so much of an academic paper. Does that make sense? So that's how I would categorize the difference of template that you want to go for. And then again, everything is on here. Like for example, if you want to do paper, where to go? Let me go to home, and then triple AI is a good template. You can just use triple AI, something like this. This will be what I consider a paper. And then you can type it down here, like something like this. You can just start typing it down. We talked about this before. I can show you guys if you don't know what this is, right? It's a system diagram, or it could also be a sequence diagram. It just depends on how you code how you design an app, and you can have LLM write this for you. You don't have to physically write it yourself. Make sense? It's just something that like what I consider like if it's not this, you're gonna have to write like 500 words paragraph to explain to me, oh, this blog goes to that blog, and that's kind of tedious for me to read. So you just do a picture, and then I'll know immediately what you're doing. Make sense? Okay, so that would be the difference of paper versus a poster. And if you do paper, just keep it 2 page. Like don't go crazy on the paper. Make sense? So that would be 1, 2, 3. And then I would say if you have the repo, these two things should be in the repo. And then you're good. You can just submit the repo and then you're good, right? That would be the bare minimum. I also have the conference website link. I'll share that link with you guys if I haven't already. That's only if you want to like showcase what you do and then add something on your resume. Does that make sense? Like that's not a required thing. Just so you know. So if you don't do that, it's totally fine. It's not like I'm not gonna fail you just because you didn't submit there. Any questions? Okay. What? The which one? The conference thing? So so the conference thing is let me find it. Hang on one sec. So there's a conference link that I sent out, which I can't find for now. Let me find it after class, and then I'll basically explain what that means. So it's a link where you submit your paper onto conference, just like Triple AI, and then that's only if you want to like showcase, hey, I've done this on my resume and I've submitted my paper to this conference. Like do that, you have a paper trail. Make sense? Yeah. But as long as you do these things, where's my as long as you do these 3 things, and then end of the day, these files is going to be part of the GitHub repository, and then you just submit the GitHub repository, then you're good. Make sense? Any questions? Good. Okay. And if it's still not clear, just email me. And I understand that everyone has their own project. So someone might feel like, hey, my video is only a minute. Someone's like, oh, I need like 5 minutes for my video. It's no problem at all. I don't really like. I'm not gonna fail you just because you give me a video that's 2 minutes and 1 second. You know what I'm saying? So, so if you need 5 minutes or if you do a video for 1 minute, it's no problem. Make sense? Any questions? Okay. My personal estimate to do all these things should take you about an hour, assuming you use large language model. If you don't use large language model, it might take you like a week or 2 weeks. But in this class, LLM is completely open. Like anyone, you actually encouraged to use like ChatGPT or large language model. Make sense? Okay. So like the whole thing should take you like less than an hour. Okay. So I'm gonna write this up and then put on the course website. So if you can't remember, don't worry about it. Yeah. Hi, come on in. Okay, let's see what else I'm missing. Yeah, no, that should be it. If you can do all this, that should be it. Good, good, bad question? Okay, okay. You just came in, so we're just talking about the items for the final submission. Yeah, but if you miss it, I'm gonna write it up online, so don't worry about it if you miss it. Yeah. Yes. Oh, in the repository. Yeah. So that's a good question. So this you can just download as a PDF file. Like you click here, it will download the PDF file, and then just upload PDF file to the GitHub repository. Yeah, that's a good question. Anything else? Okay. I'm gonna do a demonstration for this entire thing. So if you miss it, don't worry about it. The whole thing takes like 2 minutes. Okay. So I'm gonna move this to the left. And then I'm gonna demonstrate this on, where should I do it? I'm just gonna keep things simple. I'm gonna do it on the Colab. So and this whole thing is recorded. So, if you can't remember, you can always come back to the video. The good thing is, large language model make everything extremely easy, and here's why. So, okay. So if you go to pretty much any Python environment, there's going to be a terminal. And then typically my recommendation just start with terminal. And then I actually have a package called Win360 CLI. That is basically another version of Claude Code. Win360 CLI. It's pip installable, and I actually wrote this myself. I'll find a link and I'll show you how I did it. Yeah, Win360 CLI. Where did it go? I'll have to search it here. There you go, the first one. Okay, so let me show you why. Claude Code. People heard of Claude Code, right? Anyone? Raise your hand if you heard of Claude Code. A few? Yes, 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 yes. So Claude Code is a terminal tool that you have to install in the terminal window, and it will write code for you. That's basically what it is. There's one problem with Claude Code, which is it's not pip installable. I don't know if anyone had that trouble before. To use Claude Code, you have to use the NPM, the Node.js package. So that's kind of like painful. Now, that being said, I think you can probably get away with using curl. Curl stands for client URL. It's basically going to download the package directly by grabbing the source code from not grabbing source code, but download the package of the source code from the Claude website. Which if you are using bare metal GPU, or if you are on a complete blank computer, especially Windows, is going to be extremely hard to install. That's why I basically build this one. So this package is actually very neat. I basically just tell Claude Code to code another Claude Code itself, and then it just gave me some of the source code. I basically let it, I have a Max Pro subscription with Claude Code, and I just let it run for something like 10 hours overnight. And then it actually gave me most of the functionality by itself. So, a trick for you guys is if you wanna copy a large language model and get the source data out of it, especially the coding data, just say, hey, I have no context. Give me something from your knowledge base. That's the system problem that you'll be using, and then it will extract information from its knowledge base. And it's going to be very difficult to guardrail that. And typically, you can't guardrail that because that defeats the purpose of LLM. And hopefully, next session when we talk about fine tuning, you guys get an understanding of why it's almost impossible to guardrail that. You can guardrail certain topics in large language model memory. You cannot guardrail what the model is designed to do. In this case, Claude Code is designed to do coding. Make sense? So you can't guardrail the coding to against the coding itself. Does that make sense? So if I tell a coding tool to do another coding tool, what's going to happen? I'm going to recover some of the source code. Does that make sense? So that's the difference here. The only thing that's difference is I did this 100% in Python, and this one it's not. Make sense? And then all of this is complete open source. So github.com. So it's complete open source, right? Everything is here. Now, question for you guys. Am I picking a fight with Claude or no? Are they gonna get angry with this? That's the question. Who said no? No? Why?
Because it is generated by Claude. It is supposed to generate code.
Yes, but why else? There's another reason why they're not gonna fight with me.
Because it is non-profit.
No, there's a very important reason. So there's a difference between the code is doing smart things and that it needs an LLM, right? Even if I can recover some of its source code, I still need an LLM, right? So I cannot, so this is useless going out of the Anthropic world. So not only are they not going to pick a fight with me, they're actually going to thank me for doing that. Make sense? That's the logic here.
But OpenAI can buy.
Yes, that's a good point. But for the time being, they haven't done that yet, right? For the time being, they haven't done that yet. But you bring up a good point. If there's another party that's a competitor to Claude, and I release a Claude source code, or I somehow uncover part of the source code, and then someone else want to buy, then that becomes a problem. But for the time being, this is actually to the Claude's benefit, even if I was able to uncover some of the source code. Why? Because I actually rely on the API key from Anthropic. That's why. So the agent, the agentic framework, it's just a matter of, oh, if user says something, this robot is smart enough to know what to do. But it can't physically do it unless there's a large language model supporting the logic. Make sense? So I'll give you a very simple example, and we're going to see an example live. So let's say I want to code an app or something, right? Write a Python script. And then it's able to write a Python script, that's fine, but it's not going to know that, and it's not able to do that without the large language model access. So that's the logic here. So the key point of all of this, which is the entire message of today's Gen AI, still goes back to who controls the model. Like the person that controls the model weights, it's still the person that makes money. Make sense? Because everything else can be recovered. Any questions? Okay. Great. So once this is obviously pip install. You can open your computer, you can pip install it. So the benefit of doing this is, I can show you a benefit of doing this. Let's say you're in a terminal window, perhaps you have a folder, and then maybe you have a data somewhere or something, right? Or maybe it's the data you uploaded, right? So I'm gonna do pip install CLI. What is gonna happen is it's going to go on this website and pull the wheel file. The wheel file is essentially a zip folder of all of the scripts in the GitHub repository. So it's gonna pull basically all the code in here. And once it pull that code, it can then run as a command line interface. And everything behind the scene is Python based. So if you want, you can just clone this, and then you have your own, and then you can customize it based on your own desire, right? So that's why I want to release this. And then if you really want to be fancy, you can clone this repository and then build a final project over this by utilizing all of these tools here, and you don't have to rebuild the agentic AI framework. Make sense? Because one benefit of this is the backend is completely built using Pydantic AI, and Pydantic AI is let's just put it this way, it's industry kosher. Like you're able to go on the job market and then say you did the Pydantic AI, and it's able to directly pass a lot of the security checks. Like for example, LangChain, LangGraph, they're not able to pass the security checks. Like if you're in banking, if you want to do fintech, LangChain is not going to pass all that stuff. Like same thing goes with healthcare. If you go healthcare, some of these packages out there, even if you build a sophisticated package, they're not able to pass the security checks. So Pydantic AI just makes that life easier. So anyway, that's a long answer of this. Now once this is done, what I'm going to do is I'm going to explore a couple of things. So let me just show you guys what I wanted to do, and then I'll do the demo. So let's say the goal is this. Let's say you're trying to build a final project, and then the final project is like whatever, like some sort of chatbot or something, right? Up to this point, you and the large language model is on par, right? You have your own thing, LLM has its own thing, right? Like you're not you're not helping each other cohesively, right? Like right now you're kind of like separate entity, right? The way to think about this is you have to like stand closer to LLM and then really use as a tool, and then kind of like work together cohesively, right? So what that means is the humans still have the high level of functioning and planning to tell LLM to do what to do, to do what they need to do. So you have to think about it in a way that humans is the planner, an LLM is a driver. So you are not in a like you're in an Uber and then you're not driving the car, but you tell the Uber driver where to go, and then the Uber driver will drive there and hopefully safely and don't hit you or don't hit anybody else. Make sense? So that's the relationship here, and that's probably the best analogy I can give. Um, and obviously in the beginning, set up your key and token. I'm gonna do this live, but I'm not gonna record it. So I'm gonna turn off recording for just a second. Okay, so if I call this, it will kick off a command line interface that look like that. And then this is basically like its own chatbot environment that you can talk to it. And then behind the scene, the agentic AI framework is built using Pydantic. Okay, so the first thing I do, I got my personal habit is I like to have LLM know what the directory is. That's my personal habit. The reason that's the case is because then it avoids downstream. I have to say, oh, go into this folder, oh, exit out that folder, and all that crap. So have the directory somewhere in the memory. It's always going to be helpful for you. So typically what I will say is, what files do I have locally? And what it's going to do is it's going to think about a little bit, and then it has these little tools using terminal window to basically read all the files in the directory, and then it will spill out what are the files are in your directory. And this is reading the directory live right now. So it's able to say, okay, MNIST, that's a data set, California housing, that's another data set, yada, 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 things like that. So now I can say something like this. I want to explore California housing data. And from here, what I would personally do is you need to have a better plan. Because right now the entire world is your oyster, right? Anything's possible. You have colorful data sets and you don't know what to do. I think right now it's going to be the opportunity where humans need to be a little bit more prescriptive. Make sense? So you kind of need to come up with a plan for the LLM instead of letting LLM to give you a plan, right? So in the beginning, you need to have a really clear idea, as clear, as narrow as you possibly can, right? So I'm going to do a demo here. So for example, let's say my goal is to explore a data set. I actually have no idea what data set is, but let's say my goal is to explore the California housing data set, right? So I'm going to say this. I want to explore California housing data set. I want you to build a Streamlit app for me. So a app.py script. Then I want you to give me required dependency in a requirements.txt file. So this way, it's able to write app.py and the requirements.py so that you can deploy the app locally. Does that make sense? But LLM may or may not know that's what you want. But instead of having LLM guess what you want, you just tell LLM that's what you want. Make sense? Good? Okay. So from here, you can just let it run, and then it will kind of write a script for you. At this point, it's writing the code outside of in the main directory, which is in parallel to the sample data folder. So it's in parallel of this folder. So if this finishes, it will generate a code here. We're gonna let it run, and then once it finishes, we can examine the Python code. And then here, you need to make a second decision, which is if there's more things you want to add to the Python code, or if you want to deploy to Hugging Face directly. And this CLI has a tool behind the scene that help you deploy. And while this is running, I'm going to show you what it takes to deploy something to Hugging Face. So if you go to Hugging Face, spelling that wrong, Hugging Face. So we go to Hugging Face. This is the Hugging Face website, assuming you log in correctly. If you want to deploy something, you have to click on this and then say new space or something like that. And you give a name and then pick the container, and then whatever container you do, and then depends on the framework, right? Like it could be Docker, it could be Gradio, it could be blank, it could be whatever you want. And then you have to click on a bunch of things and all that stuff. And this just assume the user need to know what they need to know, right? And then you can kind of argue that this is probably asking too much of the user. Does that make sense? So that's kind of like the whole point of why I want to show you guys this. For future reference, the coding tool is going to be smart enough to help you get past all of that. So I'm actually surprised they didn't think of this. The Hugging Face didn't even think of this right now because their ideal audience is someone who knows how to code. Does that make sense? So for future reference, if you know how to code, then obviously go through the steps this way. But if you don't know, or if you need like a little handholding to getting started, then the chatbot is there to do things for you. Make sense? Questions? Okay. So now let's take a look at what's happening. So we waited a little bit. We say, okay, we want this and that, blah, blah, blah. And then now it says, perfect. I've created a comprehensive Streamlit app for exploring housing data set, blah, blah, blah. And then here are some features, things like that, right? And then, oh crap, what do I have to do? I have to do all of this, right? I have to pip install or whatever, and I have to use a command line interface to run it. What if I don't even know how to do that? Right? That's the problem, right? This still assumes that this other person in front of a screen is a programmer, right? That's still the problem here. We still haven't get past the problem. So now the idea is this. Now, if you want to throw this onto the Hugging Face, literally you can just talk to it. Make sense? But before we do that, let's examine this app.py. Just kind of take a look at what's going on inside. So there's a bunch of code. There's a little bit of page configuration. There's a little bit of decoration using CSS. You load the data, something like that. And then here, I actually don't know what's in that function, so we're going to look that up. And then there's a couple different tabs, which I'm assuming it's running the data, things like that. So maybe this works, maybe doesn't. I'm going to guess that it probably doesn't work because this actually is fetching the data from the scikit-learn package. It doesn't really allow a user to drag and drop, which is totally fine. I think you can kind of treat it as a feature, but then you can kind of like just tell LLM to redesign the app to allow user to drag and drop. Make sense? So this is kind of like you can call that a feature, or you can kind of call that a bug. But it's okay. We can see if that works. And then this is the app, right? And then this is the requirements file. And then these are the packages that are generated by basically Anthropic that are dependencies to support the app. So those are things that's being created. Now the question is this. Now let's say you're at a point that you're okay with the app, right? You want to push the Hugging Face and let other people use it. Well, how do you do? So you say something like this. I want you to publish app.py script and requirements.txt file to Hugging Face. That's not going to be it though, right? Because it doesn't know what your username is, doesn't know where to put it. Make sense? So you kind of have to tell the AI a little bit more information, right? So let's say, what is my username? My username is whatever this is, right? Eagle0504. And then usually in an app, that's a live information. Like for example, I can go to my profile, and then if I go to like whatever app, let's say this app, this information is a public information, Eagle0504. The only secret is like the token, right? Token, obviously, you don't want to tell the internet what your token is. So here, all I gotta do is I say, my Hugging Face username is whatever that is. The new space name should be, we're gonna give a name. And then let's say this is whatever, like explore housing data or something like that. So explore housing data, just like that. And then this way, behind the scene, what is happening right now is the large language model is going to try to grab these information. And the information it's going to need is this username, which is this thing here. And then this housing data, which is this thing. And then what's going to happen is it will then create a repository, and then it will push the code to that repository. So those are the steps that need to happen. And then I think, is that done? Okay, I actually did not know it's going to do that. let's see if this is actually real. If it's real, this is gonna be crazy. What is this? Explore housing data. Okay, let's see. Oh, there we go. Okay. Boom. So now the app is on the Hugging Face right now by simply just talking to it. Now it's loading by itself. Make sense? And literally the only thing I did is talk to the chatbot. So the only thing I did, let's see, let's take a look. What did I do? This is the first sentence I typed down. Yeah. What files do I have? Make sense? And then this is the second sentence I typed down. Or let's call that paragraph. How about that? This is the second paragraph I typed down, right? And then what else do I have? This is the third paragraph that I typed down. Make sense? And that's the only thing I did, right? There's no coding involved. Make sense? But then it doesn't mean I don't know anything, right? I still need to know the stuff, right? You still need to know, okay, to put together an app, especially a Streamlit application, the bare minimum is this app.py and whatever the requirement is. Make sense? So if this is the very, 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 very first time you're using Streamlit application, you may or may not know that. In that case, my recommendation will be to basically ask the LLM what's needed to put together a Streamlit application. And then a large language model will just tell you, oh, you need app.py, you need requirements. Make sense? So that information is well known. It's like well known by LLM. Any questions so far? Okay. So hopefully the app works. At least I'm hoping it works. I should don't know if it's gonna work or not because I'm doing this live and I actually don't have a script for this. Okay, so obviously there's an error. So then you go back to the app to see what the error is and see if you can debug it, right? I actually don't know if it's gonna work. So what I'm gonna do is I'm gonna try to be a little bit lazy. I am going to, what am I gonna do? I actually don't know if this is gonna work. So I'm gonna copy this whole thing. And I'm gonna say copy, and I'm gonna go here, say I saw the app on Hugging Face, and I saw this error. Paste. I have like my gut feeling is that I don't know about token size because this is a lot of tokens. And then when I design the package, there's like a max token level that it might check. But we're just gonna let this run to see how far it can take us. In this case, it's gonna check the columns. The Python script is here. So let's hit Y and then let's hit enter. Once it's confirmed, it will check the columns. So while that's loading, let's just see what this is doing. Okay, so it's reading this package and then trying to check out what the target names is or what the feature names are. Maybe they're different spelling or anything like that. So we're just gonna see how it goes. Maybe it's working, maybe it doesn't. Yeah, that's basically that's basically kind of like the whole point I want to do this, which is you guys get the idea, right? How to put things onto this app. It should be fairly easy for you to do. And then if you want to debug, it should also be fairly easy for you to do as long as you have an LLM near you. Make sense? Any questions? Okay. We'll let this run in the back end and then whatever shows up, we'll see if we can fix it. Okay. For now, let me take a pause. Any questions regarding like packages? Any questions regarding like talking to LLM, deploying your app, things like that? Because I'm pretty sure someone like one of the students in class is gonna probably deploy something on Hugging Face. I already know that, but hopefully this is easier for you. If not, then feel free to do it manually. Manually is totally fine. Good questions? Okay. All right, I'll come back to fix this and then is this already done? I don't believe that. I'm gonna run this again. No, I don't think it's fixed. What's that? I thought it's the same link, no? How California Housing Explorer. Oh, you're right. It's a different link. Oh my gosh. Oh, you're right. It is a different link. Oh my God, it's crazy. I actually did not know it's gonna do that. How much did you think? Oh, this is crazy. This is insane. Okay, this might be a little bit too smart. Okay, well, yeah, no, your read is correct. So, it basically write a Python script, uh, and then after it wrote it, it deleted it. Did everyone see that? Right? You saw it, right? After you run it, it deleted it, right? Yeah, yeah. But it's okay. This is recorded, so if people don't believe me, you can watch the recording. So what happened was you create a Python script trying to read the data on the spot, trying to understand the spelling error or whatever, right? And then you fix the script, redeploy it to Hugging Face, and then you get all that done while we're talking. That's what's happening here. Any questions? Good. Okay. Same thing goes if you use Claude. It's Claude Code is the same thing. Make sense? Okay. Um, both are actually paid. If you're using Claude Code, you have to use npm. You can't use pip install. Yeah, and then you can do it in the terminal window. Yeah, and then I don't know what laptop you're using. If you're using Windows, you have to use the WSL. You cannot use the PowerShell Windows. If you use Mac, you can just do the this npm thing. I can't remember what it is. But that's probably the harder one. There's an npm one. It's like something like npm cloud install or something like that. Yeah. Okay, yeah. I mean, I think I made the point, right? You have your data, you can explore it with LLM, you can deploy it to Hugging Face, and then this way you can then show people or whatever, do your demo or something like that. Say, okay, I have a data set, I know how to explore it. This is how I explore it. Make sense? Same goes with modeling, right? If you say, hey, push a button somewhere, I want to run a logistic regression or linear regression model, same thing, same logic. Make sense? Okay. Yeah, and then this should be live. So you can just take this, or where is it? This one. So click on that and then say embed the space. And this direct URL is going to be your app. So this one, you can then go to incognito. And it will be a live app for you. And then you can take it and then, I don't know, put on a resume or something. Make sense? Yeah. Any questions? Okay, let me check the Zoom. I don't think any questions here. Okay, so great. We're coming up in an hour. Let's take a 15-minute break and then come back. Yeah, so the purpose for this is to allow students to have the experience of basically submitting papers to a conference website. And then, I set this up so, once you submit it, you can like check the box, hey, I've been to conference or whatever. It's mostly just for your resume. It's a resume enhancement tool. Let's just put it that way, if that makes sense. It's optional, not required. So this is here if you want to do it. So I just want to mention that in case people have questions. Okay, another thing I want to mention is like someone asked questions about this package. This package is here, by the way. It's complete open source. Open source just means you can like git clone, right? You can clone this, and then you can download the source package yourself, and then you can customize the code however you want, right? I would say if that's something you want to do, it will be a bit more technical. And then the best starting point will be system and use case. System helps you understand what's existing right now, currently in this repository. And the use case is kind of like depending on what you want to do, right? So I would say the best way is probably start with the use case. And then there's like a whole list of use case that I'm trying to personally focus on when I develop this package. Like I'm not just trying to copy this entire thing. That's not the purpose. The purpose is to solve particular use case so that I can then use it myself or teach my students to use it or whatever other goal that I'm trying to focus on, right? So I would say if that's something you want to do, the best way to start will be to start with the use case and then really focus on what the use case is doing and then solve that use case and then go from there. So once you have a use case, let's say one use case is I want to build a Streamlit chatbot, something like that. Then you can then think about, okay, what's needed for the tool to improve to be able to pull that off. And then you can then update the code. So that's how you think about it that way, which is to start with the demand, start with the use case. The second thing to learn is the system diagram. So someone asked about system diagram. This is a system diagram. It's actually very small. You might have to zoom in and then go up, something like that. It really depends on like how complicated you want to go. I don't expect anyone to go down to that particular level, but only if you want. Certainly, this is possible, and obviously, I provide this for you in case someone is interested in doing this. So basically, this diagram walks you through what exactly is a building block in this repository. So that's what this diagram is talking about. On a high level, you can kind of think about it, go from here on the right-hand side, which is here. So this is the interface level. The interface level is where the terminal window is. Like where you guys see a terminal and I can type things down, that's where that is. And then afterwards, it will then go to the left-hand side. It will go on to the agent level. The agent level here is when this box is when you're gonna start hitting the Pydantic AI framework. And that's where the agentic AI comes in. And then the agentic AI is going to need to know what the tools are, and then it needs to do certain things according to what the user is asking, and then also based on what the tools it has. So it very much is playing the matching game. So I want to build a chatbot, or I want to write a Python script, but user might not know to write a Python script. I might just say I want to build a chatbot. It's up to the agent to interpret that and then say, okay, to build a chatbot, you need to write a Python script. Okay, then one of the tools is to write a Python script. So that's really the purpose here for this container. So this box here is doing that. And then all the tools are listed on the left-hand side. So for example, list files. List files means I'm reading all of the files locally in the directory. Literally is exactly same as if I go here, I can cancel this. Let's say I do an ls, and then I can then read all of this. It's the exact same thing as what I just did, right? So now I know, okay, that's there, that's there, that's there, that's there, right? And then you also know that this is actually a folder. So then what you're gonna do is cd sample data, and then you do another ls, and then you know what the data is. Make sense? So what this package is literally doing, and how I design all these tools is just to follow my own coding convention. Make sense? And here obviously the big bet is you hope that my idea is consistent with like the conventional software engineer idea, or all the software engineers at the big companies, right? Google, Amazon, Meta. Like hopefully my concept is same flavor or same habit of what they're doing, and hopefully in the beginning it is, because every programmer in the beginning, when they get inside of a computer, they're gonna do exact same thing. They're gonna do print working directory, and then they're gonna check out what the files are there, and then they're probably gonna read something. Like for example, if I want to read a markdown, I'll probably do that. It will print out the markdown file for me. This means I'm printing out the markdown for me. Make sense? So all these are command line tools that you can build in the package, and then the way that this is built is essentially just a replica of human thought process, a human engineer's thought process. That's all there is. Make sense? Okay, cool. Okay, so I want to spend the rest of time to talk about fine tuning. The thing about fine tuning is this: it looks like it's coding heavy. It can be coding heavy. It really is not, because most of the code is written by LLM nowadays, as you guys already saw. There are only a couple of things that the essence of data science still is belong to human, and then those are things that hopefully I can demonstrate to you guys. Same thing as last session, we talk about like all these different strategies of fine tuning. Still, it's up to humans to do that, right? The humans still have to point the direction where you want to go. And what I'm hoping to do is to show you guys what that look like. Given another example. So we're gonna do this complete from scratch. So let me move this here. And let's see. What we're gonna do is this. So typically what I do is I will get inside MNT folder. And then I will git clone the package. The package name is called DeepSpeed. Yeah, so this is what I'm gonna git clone. And then git clone, I'm just gonna copy that there. And this is gonna clone everything in the folder that I just showed you. This folder has pretty much everything. Most of the high level content is already here. There are things that you can do. There are things that you probably won't be able to do at this point. What I'm hoping to do is get everybody up to 0.7. Once you get to 0.7, you can pretty much fine tune anything you want at this point, in terms of language model. What's going to be really interesting is 0.8 and 0.9. And right now, there's still no leader in the industry about 0.8 and 0.9. There might be like a few, but there's no guaranteed leader. So 0.8 and 0.9 are still open space. Like if any one of you guys figure out how to do that, you're gonna have your next OpenAI. Then the next ChatGPT or next OpenAI is going to be somewhere there, like 0.8 and 0.9. I don't think it's next 5 years, probably next 2 to 3 years. There's going to be another person that figure out, and that person's not going to be like he's not going to be in his 40s. Like that's not going to happen. People in their 40s not going to do this. Like it has to be people in the 20s and in their 30s. One of these guys, like one of the one of the person in their 20s and 30s is going to magically figure this out, and he's going to be the next billionaire. And this is not a joke. People already made the prediction with Sam Altman, and Sam Altman hit this one really well. Sam Altman is the leader of 0.7. Like he magically figured out ChatGPT, and he's a leader in ChatGPT, which is what 0.7 will teach you to do. The next one is 0.8 and 0.9. So let me show you what 0.8 and 0.9 is. 0.8 is VTT. It stands for vision text to text. It's not hard to do this right now, but it's very hard to do this when the video is long. That's still difficult. No one has able to solve that problem. Now, but I personally don't know what the solution is. If I have to guess, I'm gonna guess multiple GPU because that's the only available solution right now. Unless someone somewhere figure out like some magical model that uses very little parameters, not billions, but like a few million parameters, they can probably pull that off with the limited GPU that they have. But my guess is probably gonna be GPU. Now, that's vision text to text. This last one is going to be almost nearly impossible to do right now. It's called vision speech to speech. It's a model and just one model Like you don't have to process audio to text and then process text back to audio, like none of that stuff. Just purely just a video record something that you can talk to, and then the other end of model, it will spill out answer. And answer not in text, in audio form. So that is going to be very hard to do. Like personally, I did the math myself. This folder will get you to maybe 1 epoch of training, and you probably need to spend maybe somewhere in $200 for just do 1 epoch. So no, it's not going to be like run like normal people like you and me is probably not going to do that at scale, right? But nonetheless, that 09 folder will still show you the basic building block for you to pull that off. So that's going to be what 09 is. The successful 09 is going to be one thing speed, and then second thing is accuracy of the language. And then there's one immediate use case of this, and this is going to be a big one, is a robot that is, I showed you guys the Optimus, right? Optimus. What is it called? Optimus from Tesla. Like this thing. And then there's a Chinese version called Xiaopeng Iron, like this. So basically how it works is for this robot to work, you need to have the mechanics. That's not my expertise, right? You have to talk to an engineer to figure that out. My expertise is in software. So not only like if you want to know how this thing walks around, that's not my expertise. But if you want to be able to talk to it and say, okay, there's a pile of laundry, please fold clothes for me, that kind of stuff, that's all gonna be where is it? That's all gonna be in this folder. That's like all the magic of figuring that out is all gonna be in that folder. So all that stuff in the future, this thing is gonna have like some sort of like Bluetooth to connect to the internet, and then it's gonna make API call on the spot. Because in terms of today's, like this is already pretty sophisticated that we did before. Like this kind of stuff is already pretty sophisticated, but this is not gonna fly at a millisecond level when you're trying to fold laundry, right? When you need to fold laundry, especially when you need a robot to fold laundry, you should just go fold laundry, right? Like you can't move like this and then think about, oh, agentic, oh, what tools do I have? Can I move my arm 90 degrees and then do this? And then you wait for like another 3 seconds and then you do this again. That's not gonna work, right? So all this stuff, it's no longer gonna be applicable in that use case. Make sense? Just because speed-wise, you're not catching up. So end of the day, like this robot, if it can walk around, fine, but that's not gonna make it fly. What's gonna make it fly is a robot that can walk around, that can also listen to you. And that listening part is going to be the speed of that is gonna trump everything. Like that's the crucial thing. Make sense? Okay, so hopefully I'm hoping like hopefully I can get you to 07, and then once you get to 07, you should be able to have all the basics of seeing to what's needed for 09. And then, you know, if any one of you become like the next Sam Altman, please let me know so we can work together. Okay, so let's come back here. All right, what I personally like to do is this. So I cd into the folder. And then I will go for, my plan is this. There are different students asking for different things. I think if you want to work with the image, your best shot is start with this one, because this one is directly just image data. You can run it real fast, and then you'll see the results, like almost instantly with 2 GPUs. That's something you can do. And then some students like stock data. I have another repo here regarding to what you can do if your data input is stocks, meaning that it's time series data, there are timestamps. Timestamps means you can't just freely swap the features, right? It's not like the housing data. Sorry, it's not like this, right? This one, the features are like age or number of bedroom or whatever. These features, they can be the first neuron in neural network or second neuron in neural network, no one cares. Because time is not a thing, right? The features has no timestamp. But the problem with wait, where'd it go? The problem with the stock data is now the features carry timestamp. So they have to kind of go in certain order, right? So those are things to look out for, and then that folder will pretty much give you the knowledge to show you what to do. Another caveat is you kind of have to think about how do you apply distributed computing. Not all of these needs multiple GPU, right? Like for example, stock data. Let's say like we can probably do this on the spot. Like let's say how many trading days are there in a year? Someone want to guess? There are 365 days in a year, right? And obviously there's no Saturday, Sunday. So you subtract that. It's just Monday and Friday. And then there are like 10, 20 different holidays, right? So you do the math, it comes out to about, I think 250, something like that. Yes, exactly. So they're 250, right? So what that means is I can trace a stock every day for a year. That's only gonna give me 250 points, like 250 data points. Make sense? That's not a whole lot of data. So immediately becomes a question, okay, do you even need two GPUs? Right? So anyhow, the code is here. Um, the code is here. It is set up with multiple GPU. It's not needed. Like you're gonna run that script, it's gonna take like half a second, and then it's like a blink of eye, and then it's done.
It takes 1 minute increments.
If you take 1 minute, of course, then you can use multiple GPU. Yes, 100%. Yeah. Any questions? Okay, so let's continue. Let's try this one. So CD02. Oh, sorry. CD02. There. And then what do I have here is I have a couple of scripts. I have a .py script and JSON configuration. So these two files are this one, .py and JSON. These two files are required for the computer to know how to train a model using multiple GPUs. So that's kind of like the bare minimum. Now, of course, you can break this Python script into like multiple different things, but then that's up to you and your own organization. But if I just want to be simple in terms of number of script I have to create, then that's kind of like the bare minimum. So first things first is I personally like to do everything in a UV, so pip install UV. And then once install UV, I'm gonna use UV to initiate a project. And then now this way, everything is inside of this container. So another thing I like to do is do side by side. So I go here, I go to README file. And then I pretty much just follow this command. Now, once you follow this command, you can pretty much get it work. So I'm gonna copy that. And then let's see where I am. CD into the project folder. I can just paste the code there. This will just install all the packages for me. And then you will install the packages in a contained environment, in this virtual environment. So once you do UV init, it doesn't matter what this is. This can be any name you want. But as long as you do UV init, it is by itself a virtual environment. It's not going to affect anywhere else in your computer. Okay, so we're going to give a minute. And then once that's done, you can add the weights and bias if you want to, which I will be doing that. And then you can just start running the script. The code is already written, so you don't have to struggle what the code look like. Code is here. While it's running, right? While it's running, we can quickly walk through this real fast. there is a CFAR10 neural network model, and this neural network model, it's nothing but just the LeNet5 model. So LeNet5 is this one. It's a pretty famous model. That's it. It's a pretty famous model, but it's not very complicated. So that's the model. That's where the model come from. And then what this few lines of code is doing, it's literally just to design these layers. That's what that is. And then after that, you initialize the weights. So these codes here initialize the weights for you. And then this is the forward pass. So forward pass means, let's come back to this picture. It's this picture. So forward pass means you send a picture through these layers, and then you generate some sort of output, whatever that is. Now, once you're done here, you're not done yet, right? You need to calculate the loss and then come backwards and then update the weights. So that's how these layers get better and better. Yeah. Yeah.
They've been implemented into pieces, right? But it's one picture.
You're talking about this one?
Yes.
Yeah.
It's into small pieces, but then at the end you get one output.
Yeah, this is a classification model. So what that means is the image is going to be the input, and then the output is basically a bunch of numbers.
They then do the video 08 TT.
Oh, that's a good question. It uses similar technology, but the issue with video is videos are different frames, right? So videos are basically this picture, but it is changing when time goes. Make sense? So one sample of video has many frames. Does that make sense? So one sample has multiple frames. And then the issue with that is these pixelated value in the original picture, they're the same feature in that frame, but as time move on, the numerical values change in that frame. So this model does not capture the sequential pattern of each pixel in the data. It just captures one of them at one particular timestamp and then reports it. So to answer your question, if you want to throw in a video, these layers need to be designed to capture timestamp, if that makes sense. So that would be how people do it. Yeah, and that is actually indeed how people do it. Yeah, but that's a good question. The short answer will be this architecture is simple. It is simple because there's no timestamp. This picture is just I take one picture and then that's one sample. That's it. Yeah.
Hypothetically speaking, I'm thinking of it in a way that, let's say you have the CCTV camera.
Yeah.
And then you put a chatbot to it. And then let's say whatever it sees, the chatbot records. And then you talk with the chatbot to say what happened at this specific time.
Oh, I see what you're saying. So you're saying, let's say you have a camera and then the camera is live, right? And then you're feeding a picture into the like ChatGPT or something.
Do a chatbot.
The way to do that is you're raising against two speed. I actually haven't tried this, so I don't know if it's I don't know how cohesive you can make those two speed match. So here's what you're racing against. So on one hand, you have a hard device, which is a camera that's live, right? And then depending on how good the camera is, let's say it's 30 frames per second. That's kind of like a mediocre camera, or like kind of like just a normal camera, 30 frames per second. That means every second you will have 30 frames comes in. And that means you have to, every second, you have to send 30 frames into, let's say a ChatGPT, because ChatGPT accepts image, right? And then after that, when you're talking to it, you are actually like you actually have to wait for the API to finish to send the image to the backend, go to all those GPUs in the data center, and then you have to send a sentence into the chatbot, and then wait for the image caption model to come back, and then sends the thing back, and then that speed, the speed from your computer that you're typing, go to data center, go to internet, go to data center, and come back. That need to be within your typing speed, if that makes sense. And that speed is going to be limited by the camera speed and how good the camera and how good the internet is to pass the image into the image from the camera into ChatGPT window. Does that make sense? I personally have not done it. I think there's a chance, like if let's say internet's like there's one machine that internet's fast enough. And then you somehow set it up that the camera goes into the endpoint. It's difficult. So how do I explain this? It's kind of like a queuing problem. Let's say you have a line of students, and in this case, the students is the camera frame. So students trying to walk through the door, and they're walking through the door with its own speed. You can't control it, right? Because camera speed, you can't control camera. So a line of students walk through the door, and then another person is trying to think, oh, I need 3 people, so stop. I need 3 people. But by the time that you're able to tell them, stop, I need 3 people, maybe the 3 people already left the room. So that's the speed that you're racing against. So the minute that you finish typing that question into the system and let it run through data center and come back, you probably already lost that frame in the past because it's going 30 frames per second, if that makes sense.
But then now it records that the image, I mean the video, the video, it's recorded.
You mean save the video?
Yes, it saves it in the database.
If you save the video, it then becomes it's no longer live, right? If it's save video, then the question becomes how long of a video are you saving? Are you saving 1 minute or are you saving 30 minutes? Somewhere down the road, you're gonna have to make a cut, right? So for example, Google Nest allows you to have like this monthly subscription that you can purchase, and then it can detect a person if the person show up at your door, and then the Google Nest camera will capture that person, right? And then you can subscribe monthly service, and then you can pay for basically storage for Google to save that video for you. But then that's just that's basically as if I'm pulling up a video I store on my phone and look at my phone and say, what is this? That's not live, right? It's not live to a speed that the robot need to fold laundry. Does that make sense? Like it's not up to that speed. So theoretically, you can get it done with today's technology without having to reinvent the wheel. But speed-wise, it's not going to catch up. So what you're describing is something like this. Google Nest Cam. Subscription. Like what you describe is something like this. So you have some sort of online system that store the data. So there's a video that captures something, you store data, and then user can then go back to the video and then have a conversation. That's totally possible, but that's no longer live then. Yeah, so you're racing against how fast can you save this video, and then how fast can you extract this, and how do you do that all live? So that's the speed you're racing against. I think I don't know how accurate it is. I've never used it. I think Meta Glass is probably the closest that can work. Live translate. That's probably the closest to what I just said. Like when you're having a conversation, and then you know, if you're wearing glasses, and then it hears the other end of the conversation, you probably do it. But then that's a speech-to-speech model. That's not a video speech-to-speech model. Makes sense? Yeah. The video speech-to-speech, like if you want to get to this level, folding it close, it's the speed-wise is a huge blocker. Yeah. Because it's not just like sentence by sentence, it's like every particular step of thinking process. It requires a video. Yeah. Okay. So where are we? Okay. So we're there. Okay. So I think I just installed. Let's see, what did I install? Torch Vision. Okay. I installed this. Let's go back to the README file. Okay, I'm going to install this with some bias. And now I need a API key. So what I'm going to do is go here and grab my API key for weights and bias. I'm going to stop recording for just a minute. All right, let's see, what do I need to do? Okay, so once I install all the packages, I export the API key. Then I can run the script. And the way to run the script is you go through this line of command, uv run deep speed, number of GPU is 1 or 2 or 3, something like that, and then whatever the Python script is. Okay, in this case, notice that I don't have a script inside of this project folder, right? So what I need to do is copy those things inside. So what I'm going to do is cp cfar10 into project folder. And then I'm going to cp the dsconfig into the project folder. Great. Now I can go in here and verify that I have everything. Oops. cfar10 project. Let's see. Editor. Okay. So we talked about this problem earlier. Let me show you again what the problem is. So the problem is this. Let's take a look at our GPU. NVIDIA SMI. Right now you have 2 GPUs, right? 2 GPUs. Let me turn on dark theme. So right now I have 2 GPUs, and then this 32 needs to be the product of 32 times 1 times number of GPU. So in this case, I need to change this to 64 for it to run correctly. Okay, so now I can just copy this line of code. Actually, I'm using 2 GPUs, and then put it here, and that should be working. Oh, sorry. UV, did I not add correctly? UV add. I think I might have forgot to install the package. UV add. Sorry, let me check this. Deep speed torch vision. What did I do? Deep speed. Let me try to add again. Oh, sorry. I know what the problem is. I'm not in the folder. My bad. There we go. Okay. So this should be able to kick off the training. Oh, UV add setup tools. Okay, once that's done, let me kick off the training. And then you just let it finish. This should be able to train the script. It's a CFAR10 data set, and then it's going to train a LaNet5 model over that data set. And then from here, pretty much you just, it's a waiting game. It will download data on the spot, and then run to the torch code to train it. And then we'll give it a minute to see what the performance look like. But pretty much from here, you can just kind of see what the performance is. Any questions? Good. Let's do a quick poll. Raise your hand if you're thinking about training a model for final project, just so I know. 1, 2, 3. Okay. And then the rest of students, presumably you're building some sort of app. Right, makes sense. What? Yeah, that's no problem. Yeah, feel free to change. And then from here, it's pretty much just your skill as a data scientist. You need to be able to read these accuracies and read these loss, and hopefully accuracy go up, loss go down. If not, then you need to go back to the model and then see what went wrong, right? And then once you get back to the model, it's just another data science story. Examine the loss function, examine the data, features, like all that stuff that you learn from data science class now plays into the picture. But this essentially gives you the framework to at least like train the job. While this is loading, let me show you a project that I ran before. And then hopefully can, show you guys a little bit of a passion project. And then I'll walk you guys through what I did. And hopefully this will answer some of your questions as well. Like your question, yeah. So what's going on here? Personally, I like Warren Buffett. I think he's cool. He'll make a lot of money and he's a billionaire, right? So, but the problem is, unlike other investors who writes a lot of books, because when you make money, you write a book and then you you promote your own strategy of, okay, my strategy makes a lot of money, right? Warren Buffett never wrote a book. Like I'm serious. Like you can go on Amazon, you can go on website. He never wrote anything. So he himself is a strategy, right? So that's kind of like interesting because you can kind of assume that he's right or he's wrong. If you think Warren Buffett is right, but then he doesn't write it down. But then somewhere he's somewhere on the, in terms of how he manages his company, Berkshire Hathaway, will he release some of his thought process, right? Which means the only thing you can track, if he's right, if you believe in him, it's gonna be his letter. Does that logic kind of make sense? Now, if you assume he's wrong, then you assume he's wrong. Then there's no point doing this. But if you assume there's like that 1% chance he's right, that his strategy is indeed investing in a way that's special, then you ought to be able to learn something from his data, right? So that's what this project is about. It's easier said than done. First thing is I have to scrape the data, right? That's the first step. So I go with a pretty conventional way. So basically what I did was I went on Berkshire Hathaway website. That's his website, right? And then I went to the letters. Where's the letter? Sorry, no, not this one. Yeah. Okay. So these are his letters, right? And then you can click on the recent one, 2024. To the shareholders of Berkshire Hathaway, blah, blah, blah. And then it's not that long, right? It's like 15 pages. And then somewhere down here, where'd it go? Somewhere down here is Warren Buffett. So the dude only writes letters. That's kind of like what he does. Like he doesn't write books or anything, right? So if he's right, if he truly has some wisdom in his investment strategy, this letter is kind of like the only source of truth. He either something here that he wrote we can learn from or not, right? That's kind of like the logic here. If he's right, there ought to be something here that you can learn from that beats the market, right? So what I did was this. Their code here, by the way, you can use. So basically what I did was this. First of all, you run through Mistral OCR. So Mistral is a package. Mistral is a company, and one of their models is called OCR. OCR stands for optical character recognition. So they're like Colab, tutorial, or whatever. But basically what it's doing is it's able to scrape the text from a PDF and save it in like a markdown file. So that's what it does. And then I personally find that helpful because once it's saved in a markdown file, it makes it very easy for you to turn it into a question answer pair, right? So you scrape it and then it becomes a question answer pair, and then you can save as a JSON L file, right? So you open up a first letter, each one of the index is just one page. And then you're able to do this just simply because it's package. You can just run their API. Where's the API? This one. Yeah, this is it. So you just send the PDF in there, and then it's able to give you a bunch of like JSON-L file back. You'll be able to generate these files, and then these files, one of these indexes is one page, and then I think altogether it's like 14, 15 plus 0. So those are all the pages, and then this makes it simple, right? Because this you can just say, hey, JSON-L, the first item, call the markdown key, and then you can basically send that into another LLM and say, this is my a paragraph or whatever. This is a giant paragraph. There's something here about investment wisdom. Give me some question answer pair. Right. So that's how I create a question answer pair based on his letters, based on these PDFs. And I think I did, how many did I do? I think I only did up to 26. Which is not all, I don't think it's all, but like a good amount. I think it's just 26 years of letters. So they're all here. And then once you have letters, I believe that is the Python notebook that you can use directly if you want to, Auto 2024. The code is here, by the way. If you're interested, you can then run to the code. But basically, end of the day, I want something like this, right? So what is the question that can be extracted based on this page? And then based on the question extracted from this page, and also the content of this page, what is the answer? So this immediately will give you the question answer pair. Technically speaking, you can just stop there and you can just train a large language model as like a question and answer model. But if you want to do like instructor fine tuning and you want to have the reasoning portion in there, then you need to add this third part, which is the reasoning of why Warren Buffett believes that's the right answer. And you have to really be clear on the prompt, which is not what you believe, not what the LLM believe, what Warren Buffett believe according to that page. So once you have these three things, then you can go on to one of those folder in the DeepSpeak course, and then you can run to this and train your own language model. So this way, you're actually able to force the LLM to pretty much memorize everything in that letter. Does that make sense? And then from there, you can then generate another robot that makes investment decision or trading decision based on the LLM that you just fine-tune according to that letter. So that would be how we do this end-to-end. Okay, so that's a passion project. Again, everything's online, all the code is free. You can use it if you want to, and I can send to you. And then we'll just take a look at this result, and then I'll let you guys go. Once you finish fine-tuning, you can then check out the result at this link here. And it will just give you, oops, let me just copy this. It will just give you the weights and bias page. What? Oh, I'm sorry, I have to log in. There you go. So loss is going down, accuracy is going up. I think this will probably stopping at around 80%, and that's probably it. Yeah. So you see something like this, and then you can kind of get an understanding of how good this performance is. Make sense? Any questions? Good? Okay, cool. So we can stop here, and then yeah, best of luck with projects. Email me if you have any questions. And then yeah, I'll see you guys next Friday.